Good morning, and once again, welcome to Business Math class. Before class, there were a couple of questions about the homework in 6.2, and we'll do that first, and then what we're going to do is cover the material in section 6.3. I also talked to a lady at United Missouri Bank this morning about some of the interest rates that were current, and so we'll be talking about those too. Kind of got some updated information. So we're dealing with simple interest, and I was curious what was happening with loans right now. So Holly's question was on 6.2, problem number 27, and it says at a rate of 4.5% simple interest, how long will it take for an investment to double? So the question really is, if I put in some amount of money, how long will it take for it to be twice that much? And that kind of caused some confusion not only in this class but in my other class. We talked about it in the afternoon when I met with them. My suggestion for that one was to pretend that you started out with an investment of $100 and to pretend like when it doubled it was worth $200. It's because it starts out as 100% and it ends up at a 200%, and the amount of interest you would earn would be 100%. So we want to know how long it will take for an investment to double. I think it's looking for it in terms of years, since it's not asking for anything else. So we think about the formula, and I think, whoa, we need to certainly zoom out on that a little bit. The time in terms of years, if you remember the formula, what is it, Holly? Do you remember?
Interest over divided by the principal times the rate.
Right. And her question was, what do I use for interest and what do I use for principal? They didn't give me any money. And what we're going to do is assume the principal is $100 or 100%, and the interest would be also 100, because it would double. It would go up another 100%. Which would give you principal at the end of 200%, or if we're going to just use money, $200. So the time in years is equal to $100 interest, $100 principal, and a rate. The book's rate was 0.045, right? And if you stick that in your calculator, what do you get?
22.22.
Is that repeating? Cool. So over 22 years. Is there anything else besides problem 27 on 6.2 that we needed to talk about? Yeah, Marilyn.
I just want to ask, on number 11, how did you know it was in years? Is it because it didn't say months or days?
Because it didn't say.
Okay.
When it asks for time and it doesn't specify, I would assume that they're asking for time in years.
Okay.
Because that's what the formula gives you, is time in years. If it wants it in some other way, it'll ask you for days or months or weeks.
Well, I got the right answer. I just didn't know how to label it. And then I'd look in the back, and I just wondered how it knew it wanted years.
When it doesn't tell you, then it's looking for time in years.
Okay.
And that's a great question. I think sometimes we imply things and we forget to tell people that we're implying those. The old book used to always imply that interest was ordinary if it didn't say. Does that make sense? And I think that caused some confusion. I think he's a lot better here about putting specifically whether it's ordinary or exact, where in our last book, if it didn't say, it meant ordinary. So sometimes implied things are hard when you're home doing your own homework. Who's got another question? Great. Then we'll go ahead and talk about 6.3 if everybody's got their notes. The topic is called adding interest. This should be a topic of the way you think things work. When we get to 6.4, it might be not the way you think things work. Okay? When money is when money is loaned to a borrower, the lender typically earns interest. If you're going to go to a bank and borrow money, when you pay the money back, the bank wants to make money on the fact that it gave you money. So generally, the lender makes money, so the borrower pays back more money than they actually received. The borrower receives a certain amount of money from the lender. That amount of money is called the proceeds. So if Keegan goes and takes out a loan, the amount of money that the check is made out to him for is called the proceeds of the loan. Does that make sense? Proceeds. Okay. The proceeds for a simple interest loan is the principal. So if you went and borrowed $5,000, the amount of money that the check would be made for that was given to you is $5,000. And that's true in simple interest loans. What we're going to find in 6.4 is that's not always the case in a different kind of loan. It's called a discount loan. So we're going to talk about proceeds. It's going to seem like we're using them interchangeably when we're talking about principal and proceeds in this section, but we're going to discover that it's not interchangeable in the next section. Okay? The amount of money that you would repay is called the maturity value. And the maturity value for a simple interest loan is the amount you borrowed, the principal or the proceeds, plus the interest. So we're adding interest to the proceeds or to the principal to come up with the maturity value. And you'll see there that maturity value equal principal plus interest. And that's the way you would think it would be, wouldn't it? The amount of money you pay back is equal to the amount of money you borrowed plus the amount of interest that you're required to pay. In 6.3 and 6.4, we're going to assume there are absolutely no payments made. Payments kind of add confusion to this, so what we're going to do first is assume that these are balloon loans. You borrow money, you use the money, at the end of a certain time you pay back the money. Okay, so don't worry about payments in 6.3 or 6.4. What we're going to do in 6.5 is then discuss how payments are applied when they're made. But we first want to make sure we understand how loans are handled without payments, okay? So every one of these will assume there's just one lump sum payment at the end. Is that all right? Good. So this should be pretty straightforward. A loan of $3,000 is made at 12% simple interest for 2 years. How much should be paid back? First, we need to calculate the simple interest like we did in prior sections. We're going to say I equal PRT, where P is $3,000, R is 0.12, T is 2. How much interest would we pay on a $3,000 simple interest loan, 12% for 2 years? Who's got their calculator going already? $720. Next thing we need to do then is calculate the maturity value. How much are we going to pay if no partial payments are made at the very end when the loan is due? That's exactly right. $3,000, the original principal, plus the interest. And this does seem like the way the world works. And I mean, people are going, whoa, this is not complicated. And that's because that's the kind of situations that you're used to. Once again, in 6.4, things work a little differently. Okay? Maturity value, $3,720. Next problem. A loan of $800 is made. It's at 8.5% simple interest for 17 months. What is the maturity value of the loan? Once again, you're going to calculate the interest. Once you know what the interest is, then you need to add it to the principal to come up with how much money we're going to pay back. $800. We've got 0.0885% and 17 over 12, because it's a monthly loan, so we do 17 divided by 12. Thank you. And we're going to just round that to the nearest cent, so we're going to call it 96.33 cents. Maturity value then will equal the 800 plus the 96.33 Does that work in everyone's life? Great. Okay. Next, we're going to talk about vocabulary that's actually associated with going to a lending institution and filling out paperwork and borrowing money. There's a list of vocab at the top of that next page, and so we're all talking about the same words. We will go over these. The payer or the maker is the name of the borrower. So if you go to a lending institution, then you are the payer. The payee is the name of the person or the lending institution or the bank, whatever, the business, who loaned you the money and who you're going to repay the money to. So the maker is the person doing the borrowing. The payee is the person doing the lending. Term of the note is the length of the time until the note is due. So it might be a 2-year loan or a 3-year loan. In the prior example, it was 17 months. It also might be daily. You might borrow money for just 45 days or 180 days or 270 days. Cars are commonly 36 months or 48 months, 60 months. So, you know, they can be monthly, they can be daily, they can be annual loans. Okay. Maturity value is the amount of money that you're going to repay at the end of the time when the note is due. Proceeds, we discussed that earlier. It's the amount of money that is actually received by the borrower, and the date due is the date that the loan needs to be paid back. There's an example here that talks about simple interest loans, and we're going to use this same example in 6.4 to talk about discount notes. Discount interest. And so we're going to go through this one. It's the way we've been doing things. There's nothing here different than what we've looked at. And then when we get to 6.4, we're going to do this exact same note for the exact same money and the exact same terms as discount interest, and we'll discuss it and compare the two, okay? This one says you've borrowed $7,500 for 90 days at a simple interest rate of 12% ordinary. It's already worked out. I'll put it up on the screen, but you can read down with it. We use the formula I = PRT. We've got $7,500 times 0.12 times 90 divided by 360. Interest would be $225. It's exactly the way you think it would be. Proceeds are this face value or the principal that you actually borrowed, $7,500. Maturity value would be then $7,725. Okay. Example 3 says, find the date due, the interest, the proceeds, the maturity value for the following simple interest loans. I've got a 6-month note. It's made on January 15th. 14% interest with a face value of $1,000. So what you've done is on January 15th gone to a lending institution. You've asked for $1,000 simple interest. You're paying 14%, and you said, I'll pay it back in 6 months. Question, when is it due? How'd you get July 15th? And so I just think I go January to February is 1, to March, to April, to May, to June, to July. That's right. When it's a monthly note, you don't need to go to the table of days. You can literally count forward 6 months. You don't want to use the table of days, as a matter of fact. And you're going to come up with that it's due on July 15th. And then the question is, how much interest is there? $70. Great. What are the proceeds? $1,000. That's right. The face value, the principal, the amount that you actually wrote the note for, $1,000. Maturity value would be $1,070. Great. Okay, you'll have to put your thinking cap on the next one. We've got a 4-month note. It's made, and it's a monthly note, 4 months. It's made on October the 31st, 13% interest with a face value of $600. Hardest part of this is figuring out when it's due. It's 4 months after. So, what do you think? That would be if it was daily. It's a 4-month loan. It was taken out on the last.
So it would be February 28th.
Thank you. It would be due on February the 28th. It was taken out on the last day.
So that would be 28th.
Mm-hmm.
Oh, well.
Which is better than answering February 31st, which is what someone did in my other class, and everyone laughed, and then he was embarrassed. Since it was taken out the last day of February, the last day of October, it is due the last day of February. So this one would be February 28th. I just like to put that one in so you're thinking about it. If it were a 120-day note, Karen, 120-day note, then you would add 120 days to the, yeah. So, okay. So, talk to me. Tell me, how much interest is there going to be on this 4-month note? I end up taking 600 times 0.13 times 4 divided by 12. When it says monthly note, the denominator of time is 12. $26. Great. Maturity value then is $626. The proceeds to the borrower would be $600. That's right. Did you get 626 as the maturity value? Great. Top of the next page. We have a note that has a face value of $600, interest rate of 9%, maturity value of $633.50. Find the time of the note in days. Got to do this in multiple parts. There's some things you need to think about. Holly knows the formula for time. Holly, what was that?
Time equals interest over principal times rate.
And we always know when we do that, it's time in terms of a year, right? So think about what we're asking. We've got face value 600, interest rate 9%, maturity value 633.50, and I need to find the time of the note in days. What do I have to do first to come up with some of these numbers?
Do the 633.50 over the 600 times 9%.
Good thought, but that's not quite it. She's... No, it's not 5 days. Okay, what are you saying, Marilyn?
Oh, I like to stick to $33.50 on the top number.
That's
your
right.
interest. And then you take, your 600.
How come you use that? She's making a grimace here. Where'd you come up with that number?
What?
That
Oh,
33.
subtracted.
That's your
That's-
interest.
That's right. The
That's your-
number, and again, when you've got a lot of numbers, you don't necessarily have the right numbers to just plug them into a formula, and that's what this one's all about, is getting the right numbers in the right place. You've got to ask yourself, what is the interest? Well, the interest is the difference between the maturity value and the proceeds. Okay? So we don't want to put $633.50 on the top because that's not the interest. That's the maturity
So
value.
you just subtract 600 from the 633.50.
Yes, subtract the 600 from the 633.50. So the interest, the amount of actual interest that you earned was $33.50. So times in terms of a year is, interest is $33.50. Okay, now what number goes in there for P? Is it 600 or is it 633.50?
600.
That's right, 600. Because the principal or the proceeds is the amount that you actually had to work with, yeah, is $600. So we're never going to use the $633.50 in our calculation because we need it to get interest, but we don't need it to be part of our calculation. And then we've got 9% interest, so we're going to use 0.09. So when we get done, the time in terms of a year,
Is it 62.04 or do we move the point anyway?
let's just talk about it. What did you get when you got your calculator done?
.62.
0.62 what?
04.
I like that. Okay. Now, that's in terms of a year. Is that 62 days?
No.
No, it isn't. Don't think it is. When you want days, don't just assume that the number that pops up is days, right? That is the part of a year. Go ahead, Marilyn.
Why didn't you divide that by 360 when it said ordinary point interest?
She hasn't gotten there yet.
Oh, I thought she said days.
Oh, we're going to convert it to days.
Okay.
So,
Okay.
when we convert it to days, yeah, when we're coming up with time in years, we can use. Oh, okay. And I think you're going to do a different calculation. You're going to come up with the right answer also.
Okay.
I know what you're doing. I think. I'm going to play with that one and just give me a minute.
Okay.
I like to do time in years. Come up with time in years. And again, a common mistake is that people look at that and go, then it must be 62 days because I'm interested in days. Days is what I want. But that's not it at all. That's telling me what part of a year this is. Is that okay? And the part of a year that is 0.6204, like over how much of a year? Over a half a year, right. When I see 0.6, I go, wow, this is over a half a year. How many days are there in a year, ordinary?
360.
360. So when I come up with my final answer, the number of days ought to be more than half of that, ought to be more than 180. I kind of just like to have a feel for what's happening. Okay. So I'm going to take that number to convert it to days times 360. And what number? I heard someone say the right answer.
223.
Yeah, so it's going to be approximately 223 days. Now, Marilyn said, how come I didn't take this number? I'm going to play with that one. I think you're saying if I take 0.09 divided by 360 there, I'll go to months.
Yeah, I think that's what I did.
Days, rather.
Somehow or another. When I saw the ordinary, I divided by the 360. All I did was just assume when I saw the ordinary, I divided.
And I think that's right, and I will think that one through. For some reason, and again, you'll find I'm very structured and I kind of do same in a very methodical same way. I tend to always get time in terms of a year and then make the conversion from year to whatever category I need by multiplying by the unit of measure that I want to convert it to. Like if it's months, then I multiply it times 12. If it's weeks, I multiply it times 52. If it's days, ordinary times 365. She's saying, and I'll play with that one in my calculator. She's saying if I take that and divide it there, this should come up with. Then you'd have to memorize a different formula for every unit of time. It almost seems easier to me. But again, Marilyn, I'm not very creative. I tend to be very structured. Did you get the right answer when you did that?
No.
Yeah, with like .007.
Yeah, I'm getting a different answer.
Because why would you do 360?
Well, she's saying when I saw the 0.09 divided by 360, let me think that one through. I like doing times in terms of a year. When I get there, multiply it by the 360. You get what part of a year it is, and then convert it after that. And if you look back in the notes, that's how we did our time conversions in 6.1 and 6.2. In 6.2.
All right.
Where'd you get the 60?
Yes, but then you would be memorizing a different formula for time in years, time in month. Yeah, I think it would come out right. I just hadn't thought about it that way. I like doing time in years and then converting. But when I think about it, it should work. Okay, let's take a minute and then, unless there's questions, and look at the homework. It's on page 204. You guys seem to have a knack for being very good about coming up with questions, and I don't like having you go home and be frustrated. So you can look at problems 1 through 15 for a minute, and then 21 through 29, and see what kind of questions you might have. As I look at problem 25, it does give you a date of July 16th and then tells you it's a 120-day note. And so what you're going to do with that to find the date due is go to the table of days and figure out what 120 days past July 16th is. That makes sense. You will need your table of days. And there will be a table of days attached to the next test. There will be a table of days attached to the final. We're always assuming anytime there's days and it's giving you a starting point, you can now come up with days. But number 25, in order to come up with the date due, you're going to need your table of days. And 29 has got that 5 1/3% interest. And so you're going to have to be able to handle that third in your calculator. Remember, that's a repeating but non-terminating decimal. So you're going to have to do that 1 divided by 3 plus 5 and then divided by 100 in order to handle that one. What kind of interest rates are there right now? Does anyone know? We've got all sorts of numbers that we've used. Anyone have any idea what?
7%.
Excuse me?
They're at right about 7%.
Yeah. And that would probably be and I just thought sometimes it's kind of nice when we write notes and we're going to be using them for a long period of time. It's kind of interesting to know what's current today. I checked with United Missouri Bank. They said that right now student loans are at 8 1/4. Housing loans are in the 7% thing. Car loans are someplace from 8 to 9. And interest has been going down, so they anticipate that some of that will be dropping. A lot of it's based on on what? Why? And so who made some decisions? Who in the government, do you know? Does anyone know the name of the person that? Greenspan, that's right. He's a very important person in our economy, and he makes decisions that affect the interest rates. And actually, yes, you guys are right on target. We use some interest rates as high as 14 and 16 in here, and we're using some numbers as low as 3 and 4% because it doesn't matter. We're just cranking numbers. But
They just dropped the interest rates not more than like 6 or 8
that's right.
months
They've
ago.
dropped them and
On
are
top of
anticipating
that.
them going down some more. So we're in a trend now where they're downward. But we can actually use any interest rate to make these calculations, whether interest goes up or goes down. I just think it's kind of nice to know what's current. So, okay, we're going to, if no one's got any questions, let them turn off the tapes. You can stay and work on homework, and I'll come around and help you. And when we get